I'm a professional mathematician and I'm going to show you how to problem solve hard integrals. And watch till the end because you're not going to want to miss this fancy, beautiful, definite integration trick. So here we have the integral from 0 to pi of the sine of 2024x divided by sine x dx. And how are we going to approach this? So it's a definite integral, so we don't necessarily need to find an antiderivative for the function and do a u substitution. And in fact, it's not obvious how to do it here, if it's even possible. So how are we going to approach this integral? The first observation is that 2024 is nothing special, so let's try to play around with that and see if we can find a pattern. This is how we sort of problem solve. So instead of taking 2024, let's take integral from 0 to pi of sine of nx divided by the sine of x. Okay, so n is a positive integer. And let's try to look at some values of n where we can understand the problem and try to generalize from there. That's how we do problem solving in math. So the first step is let's look at n equals 1. Okay, so for n equals 1, we're going to get the integral from 0 to pi of sine of x divided by the sine of x dx. And although this may seem easy, it's an important step in the problem solving because things are rapidly going to get complicated, but patterns are going to emerge from basic cases. This is of course the integral from 0 to pi of just 1 times dx, which is just going to equal to pi. It's the area under the graph of the constant function 1 from 0 to pi, if you like. So there we get pi. That's interesting to us. But let's try to see if the pattern keeps going on. So let's take n equals to 2. So for n equals to 2, we're going to get the integral from 0 to pi of the sine of 2x by the sine of x dx. And already we have something here. How are we going to actually simplify this? Let's use a trig identity. Okay, so trig identities would be really hard here. Okay, so we're just doing simple cases where it is possible. But there it's not possible. But let's actually get a sense of what happens. So here we're going to get the integral from 0 to pi of 2 sine x cosine x divided by the sine of x dx. And that's pretty cool because now we can see something cancels. Okay, so something cancels. We can cancel the sine of x from top and bottom, and we're just going to get 2 cos x dx. Okay, so the integral from 0 to pi of 2 times cos x dx. And that's something we can do, but let's actually visualize what's going on here. I like visualization more than just taking straight anti-differentiation. So let's do that here. All right, so let's visualize cos x, and this is going to give us a huge load of insight. Okay, even though cos x is fairly simple, if we graph cos x from 0 to pi, we know that cos of pi over 2 is going to be 0, and cos of 0 is 1. So we're going to get something that looks like this. This is going to be our graph, and at cos of pi is going to be equal to minus 1. Okay, so this is our graph, and we immediately see that if we integrate the cosine of x from 0 to pi, we've got this area here is going to cancel off with the area here. Okay, it's going to be negative area here, positive area here. There's going to be a symmetry, and therefore this integral is actually going to be 0. And the crucial property that governs a symmetry is the following. It's that cosine of pi over 2 plus x is equal to minus of the cosine of pi over 2 minus x. Okay, so if we sort of imagine the graph at pi over 2, there is a symmetry that basically if you take some value here, it's going to be negative of the value here. Okay, that's what that identity is telling us, and that implies there is a cancellation. Now that's pretty interesting because we got the integral is 0 here, but pi for n equals 1. So that may suggest that it has something to do with being even or odd. Okay, so let's explore that. Let's look at our original integral and see if we can do some trick like that. So our original integral was the integral from 0 to pi of sine of 2024x divided by sine of x dx. And here let's try to understand this function. We may not exactly know what it exactly is equal to or graph it, but let's try to understand what this function is from the perspective of pi over 2, see if there is some symmetry we can exploit. So I'm going to do that on that side of the board now. All right, so let's think about what happens when we look at the top and the bottom from this identity, okay, in terms of the symmetry around pi over 2. So let's look at what is sine of pi over 2 plus x versus sine of pi over 2 minus x. Okay, so for here I find it helpful to draw the graph of sine. We know that the graph of sine starts at 0, it goes up and does something like this, and pi over 2 is where it reaches a peak, which is going to be 1. And notice that there is a perfect symmetry around pi over 2 in the sense that the values are exactly the same. There's no negative sign in this identity, in other words, unlike for cosine. So in other words, we get that sine of pi over 2 plus x is actually equal to sine of pi over 2 minus x. There's no negative sign. Okay, so that's pretty interesting. That tells us something about the denominator of this integral, What about the numerator? What happens if we multiply with 2024? So here we're not going to graph, but we're just going to think about it. We're going to look at sine of 2024 times pi over 2 plus x, and we're going to look at sine of 2024 times pi over 2 minus x. And watch till the end, because I'm going to ask you and share with you an interesting question about what happens if we change 2024 to 2023. So here we're going to have this, and this is going to equal to the sine of 2024 times pi over 2 is going to be 1012 pi. Okay, so it's going to be 2024x plus 1012 pi. And on the other hand, if we take pi over 2 minus x to see if there's a symmetry around the line pi over 2, x equals pi over 2. So if we look at sine of 2024 times pi over 2 minus x, we're then going to get sine of, in this case, we're going to get something interesting. It's going to be minus 2024x plus 1012 pi. Now that's super interesting. What is the difference between these two functions? Well, the 1012 pi can be forgotten about. Why? Because that's a multiple of 2 pi, and sine and cosine both are 2 pi periodic. So in particular, we can sort of forget about that if we're trying to understand both quantities and just look at 2024x and minus 2024x. And here's the beautiful thing. If you think about the graph of sine, it is what we call an odd function. In other words, if you look at the graph, it has this symmetry around the y-axis, and the symmetry is going to be basically that sine of minus x is going to equal to minus of sine x. Okay? So you sort of see that sine of minus x is minus of sine x. So in particular, sine of 2024x is minus of sine of minus 2024x. So we can sort of say that these two quantities are going to be negatives of each other, just like in this case of cosine. And that's all we need, because what that tells us is that because the denominator, there's a perfect symmetry like this, there's no negative sign, but for the numerator, there is a negative sign when we go from pi over 2 plus x to pi over 2 minus x. Whatever the graph looks like, it's going to be some situation like cosine, where the definite integral from 0 to pi over 2 is going to be negative of the definite integral from pi over 2 to pi. So in particular, this integral is going to cancel off and it's going to equal to 0 because of that symmetry. And I'm going to ask you a quick question now. I'm just going to make a general observation first of all. I'm going to do it on that side of the board. So let's look at this. So what we can do is we can write the function fn of x equals to the sine of nx over the sine of x. Quite an interesting function, and it's not clear at all how to find the antiderivative of fn, but I'm going to ask you the following question. What is the integral from 0 to pi of fn of x dx when n is even and n is odd? Okay, so for n even and n odd, and there is a pattern. So we already worked out the case n equals 1. I've shown you the case of n even essentially. Okay, it's going to be the same trick. I encourage you to work it out just to practice, because I'm not just trying to show you math, I'm trying to teach you math. Okay, so here we have fn of pi over 2 plus x is going to equal to negative fn of pi over 2 minus x when n is even. Okay, and that is going to be crucial to allowing us to say this integral is equal to 0 when n is even. But what about when n is odd? Do you have any tricks for finding it out? It's quite a challenging question actually, slightly challenging at least. Think about it and drop a comment down below how I'd find this integral, for example, when 2024 is replaced with 2025, which is the year this video is getting recorded. And if you're not in 2025 anymore, I'm saying hello from the past. And if you're loving definite integrals, here's a cool one for you. I've got so many on my channel. It's a definite integral of x to the negative line of x, log of x, dx, from 0 to infinity. This definite integral is super beautiful. I've done a video on it. It's going to pop up on your screen here. I encourage you to check that out. You're going to have a blast over there. And if you're enjoying my channel content, there's math at all levels. Here's another video on another topic that's super fun that you're going to love. I'm going to see you in that video and that one eventually. Have an amazing day, and I'll catch you later.